I don't think so, but I don't know. Most of us
Mark, you have a good sound man. You can never know it's there. Okay, welcome this evening. We are just starting a bit early to try to fill every seat that we have. So I see some persons in the back half saving for others. That's fine. But if you know there's a seat beside you right now that's not being used, you're not expecting anyone special to come and sit there, would you raise your hand with the number of seats? Okay, there's a seat here. So everyone who's looking for a seat in the back, there are seats beside these people with raised hands.
No, that's right.
You may have to split up with who you're with tonight. Sorry about that.
Thank you.
Very good, very good. As the next 10 minutes unfold, there may be more people coming. We do have an overflow room, and so we'll direct those people to those rooms here in this building. Okay, we'll start in about 3 minutes.
Right here now.
What a great group. Thank you all, and thank you for your attention. My name is Bill Strong. I am Associate Director of Faculty Development. I work out of the Provost office on a part-time basis. But one of my very fun jobs is to organize this particular lecture series. And so welcome on behalf of the Provost and the University. And in a little while, we're going to have Arnold Sikkema, a physics prof here, introduce our special guest. Right now, I would like to find out just who's here. Could I have a raise of hand by those who say, I am visiting this campus tonight. This is not where I'm faculty staff. What a great group. Okay, well, thank you so much. A couple thanks need to be given. The Faculty of Natural and Applied Sciences were the group who this year were asked to discern a couple candidates that would be pitched to my office. They gave us two names. We looked at their CVs, we looked at them online, and we, along with the provost, thought, you know, Katharine would do very, very well. And this morning in chapel, if you were there, you knew that she did very, very well. So thank you to Natural Sciences for finding and bringing us Katharine. Also, some people are helping in the front there. They are the executive of the TW Environment Club. So I want to thank the people who are helping direct traffic. What is the Distinguished Lecturer Series? What is its purpose? It is to bring to campus the best evangelical scholars and leaders who are able to articulate an integrated world and life view that shows the lordship of Jesus Christ over every discipline and activity in higher education. Previous speakers we have had include James K.A. Smith, Calvin DeWitt, Stephen Evans, Chris Seipel, and N.T. Wright. Tonight, of course, we are very, very pleased to have Dr. Katharine Hayhoe, who is Associate Professor and Director of the Climate Science Center at Texas Tech University. Lead is Arnold, Dr. Arnold Sikaba from Physics will be introducing Katharine. He knows her well, follows her work. And then we'll have Katharine speak for about half an hour to 40 minutes. After that, we'll have questions and answers. So think of questions you may have, write them down, or you may tweet them. You may tweet them to Arnold's phone, and that is hashtag Katharine Hayhoe TWU, all one phrase.
Just Hayhoe. Hayhoe TWU.
Just Hayhoe.
Hayhoe TWU.
There you go. And I know you've heard this before, Hayhoe, there we'll go, and we'll be straight. If she had a nickel for every time she's heard that phrase, she'd have about $1.95, right? No more? Okay. All right. Anyway, welcome here. Arnold, come introduce our special guest.
Okay, so yeah, thank you, Bill, and thank you all for coming. There are still a couple of spaces here and there. Are they available for people who are looking for a place to sit? Okay, so there are still, if you're near the door and you want a seat, there's still 2 or 3 seats, or 4. Excellent. So it's a great pleasure to introduce to you Katharine Hayhoe. She's a climate scientist. She's an expert science communicator. I guess you'll find that out tonight for sure. She's been documentaries. She's a Canadian. She has her She has her Bachelor's of Science from the University of Toronto in Physics and Astronomy. After that, she obtained her Master's and Doctorate from the University of Illinois at Urbana-Champaign in Atmospheric Science. She's currently an Associate Professor in the Department of Political Science and Director of the Climate Science Center at Texas Tech University in Lubbock, Texas. Her research focuses on how climate change affects regional climate and human systems in the natural environment in the regional perspective. She has over 100 peer-reviewed publications. Scientific work is significant and it is of significant impact. Just to give you an idea, perhaps you've seen some of the publicity, Time magazine this year acknowledged her as one of the world's 100 most influential people. And a couple years ago, you also can tell that in the Christian community, she's highly respected because in 2012, Christianity Today recognized her as one of the 50 women to watch. And so I guess we're all going to be watching Katharine tonight. Now, together with her husband, Andrew Farley, who's a pastor and a linguistics professor, they have undergone at least a couple of important projects. One of them is a book written with her husband called A Climate for Change, Global Warming Facts for Faith-Based Decisions. And her other project with her husband is they have a 7-year-old son. So it's been a pleasure to have Katharine here. She arrived yesterday and we had a number of us had dinner with her last night and this morning. Some of you might have heard her on CBC radio. She was interviewed at 6:51 a.m., which meant a couple of us drove over to CBC headquarters early this morning. I had some Timmies on the way there. And she spoke at chapel, and she spoke in a geography class, and she's speaking tonight. She'll also be speaking tomorrow morning as a special feature for the faculty alone. And then she'll be doing a chapel presentation as well, another chapel presentation at 11 o'clock. I'll tell you the title of that. Maybe we'll mention it here as well. So, so the format is that Katharine will speak for however long she wishes, and then we'll have I'll come up and introduce the Q&A and say a few things, give her a minute to catch her breath, and then we'll have the Q&A. So, without any further ado, let's all welcome Katharine.
Thank you, everybody. It's great to be here. People often give me some grief about my last name. I have many, many relatives and cousins, so if you know a Hayhoe, they are a cousin. But the benefit of this last name is two things. First of all, nobody ever forgets it. And second of all, there are some great theme songs. I'm not just talking about Snow White and the Seven Dwarfs. Other ones. So what I want to talk to you here about tonight is something that really I think Trinity Western's all about too, and that is about integrating what we do, what we study, what we know about the world around us with our faith. The issue of climate change is particularly contentious. I live in Texas. When I moved to Texas, by that time I kind of realized what I was going to get into. I felt a little bit like moving to Africa in the 1800s. I wasn't sure if the natives were going to pop me into the stew pot. But it turned out that they were actually very, very friendly. And I have learned an enormous amount and developed a tremendous respect for people who we don't always see eye to eye on in science, but we usually do on faith. And I think with a little work, a little effort, we can see eye to eye on the science as well. So what I want to talk about tonight, my central premise, so to speak, is this. Faith and science are completely different, but they're complementary and they are essential to understanding and responding to the challenges that we face today. I don't think that we can do that without one and the other working together. And I really believe that climate change is one of the most urgent challenges we face today, as well as a challenge that we need both our science and our faith to tackle. What do I mean by this? What do I mean by the fact that they're so different? Well, one of the most frequent questions that I get is, do you believe in global warming? Or it's often phrased more along the lines of, so you believe in global warming? My answer to that is no. I don't believe in global warming. And that usually shocks people enough that they're willing to listen to what I have to say next. What I want to do is I want to give us a couple of definitions to start off with. If you use Google, I highly recommend it, you will get this definition. Faith is defined as a strong belief that is based on spiritual apprehension rather than proof. What is science? Science is defined as the systematic study of the physical and natural world through observation and experiment, in other words, proof. A better definition, I think, comes from the book of Hebrews, where faith is defined as the evidence of things not seen. If I could go back in time and sit there beside the author of Hebrews and nudge his arm as he was writing, I would suggest that he add this to the verse, that science is the substance of reality here and now, not things hoped for in the future, and it is the evidence of things we do see. So that is why I do not believe in global warming. I believe in God. I look at the evidence around us to determine whether climate is changing, whether humans are involved in that, and what it is that we might be able to do about it. But the science can only take us so far. Science is not complete in and of itself. Science is a tool that we use to understand the world around us. So for example, in the area of climate change, science can answer questions for us, like, is climate changing? Science can then answer questions like, why is climate changing? Is this microphone off? I'm getting some bad feedback here. Am I supposed to?
Should be okay.
There we go. I think I, no?
Turn it off.
No, it's not off. There we go. That's the way to turn it on. Yeah, there's nothing like technology. So, as I was saying, science can tell you how to unplug things. Science can tell you whether climate is changing. Science can tell you why it's changing. And science can even tell us, if we do X, here are the likely results. If we do Y, here are the other results. But that is where science ends. Because it is rare that we encounter a decision in our lives that is black and white. Now, this may happen once in a while, and if you have such a decision in front of you, congratulations. Treasure it. Remember it. Because in our lives, we're constantly making decisions where there are many shades of gray. There are pluses and minuses to everything we do. That is where our faith comes in. For many of us, our values come from our faith, and our values determine the choices that we make, the decisions that we make, and the outcomes that result. So with the situation of climate change, our decision of whether to acknowledge whether it's real or not, whether to take action on it or not, if we do take action, what to do about it, those are not scientific decisions. Those are value-based decisions, and that is where our faith comes in. That is where we have to look to what is in our heart, not what is in our head, to figure out what we think is the right thing to do. And what we think is the right thing to do might be completely different than someone else because we have different values, but our values are central to who we are. It's part of our identity. It's what makes us us. And that's why it is so important, I believe, not to have a schizophrenic perspective on the world, but to see ourselves as whole people who integrate our facts with our faith. So what I'm going to do is kind of walk through how I integrate my facts with my faith. I'm going to start off with the science because I am a scientist, but then I'm going to transition from the science into the faith to talk about, well, how do we think about this issue? How do I reflect on this issue given what I know about facts? So the most basic fact that we have to start with, I feel like there's a hidden microphone somewhere, so I keep going to keep back my turn in this direction. The most basic fact that we have to start with is climate changing? And I have to say the most frequent question I get, besides why is your name Hayhoe, is why is it so freezing outside? Usually accompanied with a look like this lady is giving us. I only get this question but it even happens in Texas. My mother, who lives in Toronto, was so excited when we moved to Texas. She was coming down in April for our baby shower many years ago. And she said, well, what should I bring to wear? Can I bring shorts? And I said, yes, you can bring shorts. It's been warm and sunny. You'll love it. Now, of course, the Texans weren't wearing shorts. But, you know, we would be wearing shorts. So my poor mother arrives in the middle of April in Texas with a suitcase full of nice summer skirts and shorts, and we had an ice storm. And it was freezing, and everything was covered in ice. So she was giving me this look. Now, this was actually in reference to Chicago, which was very cold last summer, and Chicago Tribune wrote a story, which was a very good story. This was a very good story. Look at this headline. They got it right. They said, despite the winter chill, it's winter. The world is still warming. And in fact, if you looked around the world last January, the world was pretty much all warmer than average. Red here means warmer than average. Where was it cooler than average? Right where most of the US major media outlets are located. So we heard a lot about the cold weather last winter because that's where they were. Here's what we have to recognize. Weather is what we as humans are built to remember. Our brains are really good at remembering weather. I bet that you can remember some weather event. In fact, I often start off my classes by asking each student to tell a story of something that happened in their lives related to weather. And they have stories about tornadoes and floods, and dust storms and hailstorms, and all kinds of things because we remember weather. Weather is like a single tree. Climate is the forest. So we do not study a single tree in isolation. We have to study that tree along with all the other trees, and not just all the other trees, but how they've been behaving over 20, 30, 50, 80, 100 years. Not the single day that they have. Why is this so important? Well, if you look at the news the past couple of years, you hear a fair amount of people talking about how global warming has slowed down or stopped. Where do people get this from? They get it from looking at the global temperature record and picking whatever period they want. And if you pick whatever period you want from the global temperature record, you can make it do pretty much whatever you want. In fact, I really believe that I could make it play Twinkle Twinkle Little Star out of the right data points. But the reality is, as scientists, and I believe as Christians too, we do not have the right to pick the facts that suit us and ignore the ones that do not. And in this case, the facts that do not suit us are the ones that connect those red periods. The truth of the matter is that over short periods of time, 10 years or so, we do see changes, slower warming, faster warming, But over the long term, this is what it looks like. This is the exact same data, I just made it all the same color. So you can see what's happening. Now this is global, and of course we live in a country. If you look at Canada, this is what our temperature trends look like across Canada. In the winter, in spring on the top, in the summer and fall on the bottom. Why do we care about these temperature changes? It's not because we would notice a 2 degrees Celsius difference. I mean, there's a 2 degrees Celsius difference between this room and the atrium out there. Why do we care about it is because it is affecting our world and it's affecting our lives in ways that we do notice. Let me give you some examples. I have to apologize here because I do a lot of my work in the States, and so a lot of the figures that I contribute my data towards are of the US. And so I try to find figures as much as I can from Canada, but we don't have as many good figures to do analysis here. I do what I can. I'm trying. So here's the US, and just picture that we're just kind of right up there in the corner of that area. So we see that our growing season has got a lot longer and our winters are getting a lot warmer. Why do we care about warmer winters? Well, as I mentioned in chapel this morning, one of the reasons we care is the mountain pine beetle has been overwintering. In other words, our winters are not cold enough anymore to kill it off. So when the new season comes along, we have all of the previous generation of beetles and we have the new generation on top of it. And these beetles are eating their way through our forests, killing millions of acres because it's not cold enough to kill them all. We are seeing massive heat waves around the world like we've never seen before. In Australia 2 years ago, they had this heat wave where it was so extreme they had to add a new color to their temperature map. This is 54 degrees Celsius. They've never had that before. In the summer of 2003, they had a heat wave in Western Europe, an extended heat wave for 3 weeks that killed 70,000 people. That's 20 times more people than died in 9/11. And that is why Europeans say things like climate change is a greater risk than terrorism, because more people have died because of it. We're seeing changes in our rainfall patterns. In general, Canada is getting wet. It's getting a lot wetter farther up north. It isn't just happening kind of all nicely spread out over the year. What we are seeing is that there's more frequent downpours, more frequent heavy rain, and even snow events because, again, it's winter sometimes. What does this look like in practical terms? It looks like this in Calgary last year. It looks like this in Toronto last year. For those of you who are in chapel, I'm not showing the next picture. This girl decided to get back in her car head first. It was quite a funny picture. And then it looks like where I live in West Texas 2 weeks ago. That's our football stadium up there, and those are cars underwater on a 6-lane highway. These are the types of impacts that we are seeing as a result of the changing climate. It's not about a 1 or 2 degree warming, it's about crazy stuff. If we look around Canada, we see decreases in things like cold nights, cold days, frost days, dry days, and snowfall. We see increases in extreme heat, in the amount of precipitation we're getting, and we even see increases in snowfall up north. Why is that? It's because if you remember back here, remember this? Our precipitation is increasing up north, and I have news, it's still cold enough to snow at Nunavut. And it will be for a very long time. So more precipitation means more snow in Nunavut. Because of global warming, yes, more snow. What other changes are we seeing? Well, both in the US and in Canada, this is for Canada, we are seeing increases in the area burned by wildfire that match our temperature very well. The black is the area burned, the red is the observed temperature, and the green is what we think the temperature would be as a result of both natural and human factors. So it's showing that it's matching quite well with what's really happening. Now, it's not all like this. You might have heard in the news recently, the Daily Mail in the UK ran a series of stories telling us that our Arctic sea ice is actually recovering. Our Arctic sea ice is doing very well. And yes, it is recovering if you look at the last 2 years. Notice that this figure actually begins a long time ago. So what if you look at all the data? Gives us a little different picture. You get the point here. You don't look at a tree, you look at the whole forest. If you look at what the sea ice used to look like in the summer in 1980 when the satellites first started taking their observations, and you look at what it was in 2012, you can see the difference. It's taken at the same time of year. It was 3 years ago now that the first freighters made it all the way across the Arctic without an icebreaker. Commercial traffic is opening up in the Arctic. It's not just about that. A couple of years ago, I remember in the summer, I was reading stories of kayakers up in the Arctic who were reporting that they saw strange things poking up that looked suspiciously like periscopes. They got home and they tried to report them, and everybody's like, oh, you were smoking a bit too much weed up there, because we all know why you went. Turns out they were correct, because up there we have enormous oil and gas reserves, and every country up there, including Denmark and Russia, is scoping out exactly where their continental shelf lies, because they want to lay claim to all the resources that are going to be available as soon as this stuff melts. Which, by the way, is why it's melting, but we'll get to that in a minute. Down where I live, people care a lot about hurricanes, and the reason why hurricanes are connected to a warmer climate is because the warmer ocean water powers the hurricanes. You can't have hurricanes until the water gets warm enough. The warmer the water, the stronger the hurricane. So we aren't seeing any more frequent hurricanes at all. The numbers are about the same as they've ever been, but we are definitely seeing stronger hurricanes. When those hurricanes come, they're coming over higher sea level. So the storm surges are also getting worse. If you look around the world, you see that our weather and climate-related billion-plus dollar disasters are on the rise. Some years are better than others, but we are seeing increasing numbers. In 2013, we hit a record number of billion-dollar disasters. If you look at the list, there was a very long list, and we were on the list at number 6. I cut it there, it went like 40 more down. But look at this list. You've got Central Europe, you've got the Philippines, you've got China and Japan, Eastern China, Brazil, and Canada. Starting at 22 billion, going down to 5 here. We're getting to the point now where we have reports from radical environmental organizations like the Toronto Dominion Bank. You never knew that, did you? Radical organizations like TD are releasing reports saying that natural disasters will cost us billions of dollars because of our decaying infrastructure, which is also being threatened by climate change, because climate change is exacerbating the risk of many of these events. You think of it kind of as you always have a chance of rolling a double 6 with 2 dice. The double 6 is, say, the Calgary floods. What climate change is doing, and we're seeing this happening in our data and observations, we are seeing that one by one, those other numbers are being replaced with more 6s. So now the chance of that killer heat wave is twice what it was 100 years ago. Now the chance of that heavy downpour is 4 times what it was 100 years ago. We're seeing the risk of these events changing. All around us, our world is changing rapidly. The best place to grow blueberries, I'm happy to report, is now gone over the border into Canada. We are now officially the blueberry winners of the world. We beat out Maine. In Japan, they have a cherry blossom festival, and they have recorded the date of that festival for over 1,000 years. Those cherry trees are now blooming 3 weeks earlier on average in the year than they ever have in 1,000 years, because spring's coming early. Around the world, in places where people live off $1 or $2 a day, they are seeing the rainfall patterns become increasingly unstable, to the point where they can't feed their families anymore because the rains they always depended on are no longer there. Or when they come, they're coming in these downpours that just wipe out their crops. And last but not least, we're seeing parks like Glacier National Park, which when it was first named had over 150 glaciers. We're seeing now it has glaciers left like this. They're still calling that a glacier. It was one of the last 30 glaciers in Glacier National Park. And when my PhD advisor took his 40th wedding anniversary last year, he told me he was going to Montana to go to Glacier National Park. And I said, well, that's nice. Any particular reason? He said, yeah, I just want to see the glaciers before they're gone. And then this summer, another colleague of mine told me he was going. And I said, let me guess. And he said, yeah, I'm going to see them before they're gone. They're looking for a new name, possibly a corporate sponsor. TD Day. When we look around the world, we see evidence of a warming climate in things that we have in our own backyards. When the tulips bloom, when the peach tree flowers, what types of birds we see and when, what types of species we see growing. 26,500 indicators of a warming climate in God's creation. Not our satellites, not our thermometers, not even our scientific data. This is creation telling us that something is happening. So is climate changing? The science says, yes, it is. And those are the facts. Well, then we get into the question of why is it changing? And the answer to this is very easy. It's because Al Gore told us so. Next. No, it is not because Al Gore told us so. What we don't often realize is that climate scientists actually study the Earth's climate. We didn't start studying human activity until we figured out it might be a problem. We spent many, many, many years, decades, and even centuries. Climate science is actually a very old field. The original climate science dates back to the early 1800s. We spent many years studying the natural influences on climate. So before we can say that it's going to be humans causing climate change right now, we have to make sure that we can't blame it on what I would call the natural suspects. The sun is one of the biggest natural suspects that we know has caused climate to change in the past. And then there's another natural suspect. You know where this is going, right? Yeah. Natural cycles. We know that climate has changed in the past, even if we have children, especially if we have children, because we've watched this movie about 25 million times. And we know these movies are always correct. So before we can say that climate is changing because of humans, we have to see if we can just pin this on the sun or pin it on a natural cycle, because that would be a lot easier. Because what is the sun we're causing climate to change? It's done it before, it always evens out in the end. What if it's a natural cycle? Even better, we know cycles even out because that's what cycles do. We just wait, maybe another decade, maybe another 20 years, and then we'll be okay again. So that's why it's so important to look at these things and figure out if we can pin it on these natural causes. And these are good questions because, like I said, we know that reduced energy from the sun contributed to a little ice age. And we know that there are large natural cycles in the Earth's climate over time. So could it be the sun? Well, if it's the sun, and if we're getting warmer, that means that energy from the sun must be going, give me a thumbs up or a thumbs down. If it's getting warmer because of a change in energy from the sun, is it going up? Sun's energy going up, or sun's energy going down? Up. Thank you. Up is the correct answer. So let's look at the energy from the sun. The purple line is energy from the sun. We have an 11-year sunspot cycle and then a long-term systematic trend. And then the orange is the Earth's temperature. Again, the year-to-year variation in the long-term trend. Up until the 1970s, okay, we're good. They're both going up. But since the 1970s, energy from the sun has been going down. So if our temperature were being controlled by the sun right now, we'd be getting cooler, not warmer. The sun has an alibi, and we can't break it. Okay. We still got natural cycles though. What we have to recognize though is that natural cycles inside the Earth system are just like a teeter-totter. All they do is move heat around. They move it from east to west, north to south, and most of all they move it from ocean to atmosphere and back again. Natural cycles can't create or destroy heat. That would violate conservation of energy. All they do is move it around. So if the air, which is where we live and where we measure temperature, if our atmosphere was getting warmer because of a natural cycle, what's the number one candidate where that heat would be coming from? And I'll give you a clue that's on this slide. Yes, it's the ocean. Very good. So let's look at the heat content of the ocean and the atmosphere. If we look at the change in the heat content of the ocean in blue, and the atmosphere, land, and ice, the cryosphere, in green, we see that when we see an increase in air temperature, it is literally the tip of the iceberg of global warming. The ocean is absorbing 20 times more heat, and that is measured in exajoules, 20 times more heat than what we see happening in the atmosphere and the land and all the melting ice put together. So that's why it can't be one of these natural cycles inside the Earth system, because the whole thing is getting warmer. But you may say, well, there is another type of natural cycle. And there is. This is a really fascinating cycle, given my own background in astronomy. It turns out that the Earth's orbit changes over time. It becomes more circular and then more oval shaped. And the tilt of the Earth's axis also changes over time. This is the reason why our North Star today will not be the North Star in 10,000 years. Because the axis of our planet will be pointing to the sky. This is why when people built ancient monuments like the pyramids, they appear to be extremely carefully aligned, pointing at nothing. Because the sky was different back then, and they were pointing at something when they were built. So people have been able to use this information to actually even date some ancient monuments. How far back in time do you have to go before you'll be pointing at something? And there's even a little program you can get to run on your laptop or your computer that runs the sky back in time so you can see what it looked like 6,000 years ago or 8,000 years ago. It's really cool. So this, it turns out, is what causes the ice ages. These tilts and wobbles in the Earth's orbit alter the amount of sunlight that we get. And this is responsible for pushing us into the ice ages and then bringing us back out again. So the natural question is, given this, and specifically this, the natural question is, are we not just recovering from the last ice age, right? Well, it turns out that the last ice age ended quite a long time ago. And if we look at the Earth's temperature over the course of human civilization, so to speak, on our planet, our temperature was actually on a bit of a long-term decline. Our temperature was going down until something happened. The Industrial Revolution. And at that point, carbon dioxide and temperature both shot straight up. There we go. You can actually calculate from basic math when the next ice age should be coming. And they've concluded that pretty much it should be coming any day now. Now, remember, these are geologists. So any day now is like 1,000 years, 2,000 years. So don't get all worried. Don't start hoarding all your acorns because you don't have to worry about that yet. And in fact, what these people concluded when they did their analysis was that we have indefinitely delayed the onset of the next ice age for all the messing we've done with the atmosphere. Now, let's get this straight. Another ice age is, number one, not a good thing. What's the best thing for human civilization? A nice, stable climate. So we don't want another ice age, but we have actually gone a little bit too far in the other direction. And that's our problem. So the situation we have is that if it were the sun, we'd be getting cooler. We're not. If it was natural cycles, only part of the planet would be warming, but the whole thing is from the bottom of the ocean to the top of the troposphere is all warming. Can't be the Earth's orbit because the next thing coming is an ice age. Only at this point, the intellectual permission to look elsewhere, to say what else could it be. And when we look elsewhere, we don't have to look too far because we already saw a monster clue, didn't we? The monster clue being over here. The Industrial Revolution was when we figured out how to dig enormous amounts of coal and gas and oil out of the ground and burn it. Now, we had been doing that before, but just not at as big a scale. Yeah. I could just turn it off and use this, but then you have to plug it back in. Okay. I got sounding all right. So, we have pretty good records of how much of the stuff we've been burning. Cement manufacturing also contributes a little bit, but whenever we burn coal and gas and oil, what we're doing is we're releasing that carbon into the atmosphere. It is carbon that was in the ground that would eventually make it to the atmosphere, yeah, but it would make it to the atmosphere over thousands and even millions of years in the future, if the planet was still around by then, not in like a year or two. So we are massively speeding up this release of carbon into the atmosphere. Why does this matter? It matters because we have this incredible atmosphere that has these amazing heat-trapping gases in it. These gases keep our planet much warmer than it would be otherwise. Our planet would literally be a frozen ball of ice if we didn't have these incredible, naturally occurring heat-trapping gases in the atmosphere. What happens is, just like a blanket, the sun's energy comes down, heats the Earth heats up and re-radiates. Now, how do we stay warm at night with a blanket? The blanket traps our body heat. Exactly. That's exactly what these heat-trapping gases do in our atmosphere. They trap our body heat, not our personal body heat. Look at the antics. Well, this is natural, right? Yeah, it's entirely natural. So what's the problem? The problem is that we are taking a natural thing, a good thing, a healthy thing, a perfectly balanced and perfectly designed thing, and we are adding to it just a little bit. So you could take medicine, and medicine is good and healthy. What happens if you take an overdose of medicine? We need food to survive. It's an essential part of being human. What happens if we eat too much food or the wrong kind of food? Paul tells Timothy to drink a little wine for his stomach's sake, but what happens if we drink too much? We know that we have things that have been given to us as gifts that we are to use in moderation, but when we use too much of them, they turn into a bad thing. We all know that. So in and of itself, this whole deal is not a bad thing. It's just that we've done too much. And that is kind of the story of our existence today, isn't it? We're never really happy with enough. We always want more. And more never quite ends up being as good as we thought it would be. And in this case, more has ended up being a lot worse than we thought it would be. So when we look at the planet, we ideally would like to have a planet that looks exactly the same as ours, maybe on the other side of the sun, but doesn't have people on it. And then if our planet were warming and that planet weren't, then we'd know it'd have to be us, right? Because that's the only difference. We don't have that other planet. It's a bit too late to ask God for it. But what we do is using the most powerful supercomputers in the world, we build physics-based models of our planet system. We rigorously test them against all kinds of observational data. Scientists is really hard because this is our lab. I often get people coming, a video crew comes and they're like, can I film your lab? And I'm like, my lab? I'm going to be really honest with you, this is my lab. Supercomputers. They're always a little disappointed when I show them supercomputers. My colleagues, I work with colleagues at GFDL in Princeton. My colleagues actually basically put a poster on their supercomputer, a pretty poster of a mountain, because they got so sick of the film crews coming in and saying, this is it. So now they put a poster to take a picture of. So we build these physics and chemistry and biology-based models. There are tens of thousands of lines of code, and we use these to create an Earth with no people. And this is what it looks like. The black line is the Earth's real temperature that we observe with thermometers. Hundreds, thousands of thermometers around the world, carefully averaged. The green is what the temperature of our Earth would be with natural cycles, changes in energy from the sun, even volcanic eruptions. That's why we have a cooling right here. We had a big volcanic eruption right here, Pinatubo. Volcanoes act a little bit like an umbrella for the Earth for about a year or two after their eruption. So this is the Earth with no people, and this is the Earth with people. What is the difference between these two? The only difference is adding human emissions of these heat-trapping gases. That is the only difference. Only by adding that can we explain our current warming. So why is climate changing? The science says it's got to be these increasing levels of heat-trapping gases because every other reason has an alibi. And even if we could think of another reason, we would have to explain how these heat-trapping gases were not trapping heat. You see what I mean? Like, you can put carbon dioxide in a chamber, and you can put it in the lab, and I did this as a third-year undergrad. You can measure how much heat it traps. And we know how much stuff there is in the atmosphere, so you have to explain somehow how it's not trapping heat. And nobody's been able to do that. Now, you may think what I'm talking about is some pretty new stuff. You may think that we've been doing this for, 10, 20, maybe 30 years. These are the fathers of our field. We knew about that natural blanket that our planet has in the early 1800s. Fourier discovered it, along with an incredible amount of things. If you could just pickle his brain, I would take him over Einstein any day. A Irish chemist knew that these gases were leaking out whenever we mined coal. He knew that in the 1920s. This man here was the first man to calculate a climate model. You might say, well, hang on, I know we didn't have computers back in the 1890s. How did he do it? He did it by hand. It took him 2 years. His wife left him. So I personally am very grateful for supercomputers. It enables me to stay married. This is how long we have been doing this science, almost 200 years. Nothing I just showed you is new. It is very, very old. We've gotten to the point now where if you look in the literature, 97% of papers published in the literature agree that not only is climate changing, but humans are the primary cause. And you might say, well, it's only 97%. Let me put it to you this way. If 97% of engineers say that the bridge is going to collapse, 3% say, no, don't worry, who are you going to believe? A little different, isn't it? Substitute airplane for bridge, and I think we're still a little bit more different. So this is the situation that we are in today. So, let me get this up here. By the way, if you want any more information on the science, because I'm going to kind of leave the science and start talking about the other stuff. If you have any more about whatabouts, but I heard this, or I heard that, or what about this? There's this awesome website called Skeptical Science. It's put together by John Cook, who is also a Christian living in Australia. And he answers every single whatabout question you could possibly imagine on this website. He has a short answer, he has a long answer, and then he has the full enchilada. That's a word I learned in Texas. With all the links to scientific papers and original figures and all that kind of stuff. So that's the science. Now we're on to the why care. Now for many of us, we may be saying, okay, I'm with you on the whole climate change thing, and I'm even with you on the humans being responsible thing. But honestly, it's so far off. It only really matters to the polar bear. Or maybe when I look like this lady and have little grandchildren or great-grandchildren, then it matters. That's how we think about climate change. But the truth of the matter is that climate change is here and now. Start here by telling you a story about a little town called Kivalina. Kivalina is up in northwestern Alaska. Kivalina is preparing to evacuate. The problem is they have no money and they have nowhere to go. The people have lived in Kivalina ever since the ship arrived and built a school and then made it mandatory to send your kids to school. They'd only been camping there for the summer because they traditionally traveled around. You can imagine how mad some people were. Why did you say we had to camp there this year? Now we're stuck for 200 years because you said we had to camp there. So they're there. In the 1800s, though, the school was closely followed by an Anglican missionary. The entire village became Christians, and now Easter is the biggest day of the year for them. They stay up all night to see the dawn on Easter and to celebrate the return of Christ to the world. This island used to be buffered by protective sea ice, so that when the autumn and winter storms hit, they were coming over ice. But nowadays, the ice isn't there anymore. And so when the storms are coming, they're coming on unprotected land. So they are putting up these enormous bulwarks to try to keep their land from washing away, but every time a storm comes, half of these disappear. Many of their buildings look like this. The school president's house disappeared a couple years ago, the school principal's house. It looks like he's looking at it there, but I don't think he is. It's not just that the ice is coming later, the ground that their towns are built on used to be permanently frozen. It is not permanently frozen anymore. It is melting into a loose rubble of rock, sand, and water. Enormous sinkholes are opening up across Alaska, Nunavut, and the Arctic. In Alaska alone, there's almost 300 native villages at imminent risk, and they have nowhere to go. This is happening now. We're seeing, right here where we live, we are seeing more heavy downpours now. And we're seeing stronger snowstorms now because we still have winter and there's more water up in the air because more water evaporates when it's warmer. We're already seeing stronger hurricanes now, and we're seeing really bad heat waves now. If you're interested in finding out more about the ways that we are seeing climate changing today, I strongly recommend this documentary that came out this year. It's a Showtime series. I won't lie, I got a little nervous when I said Showtime. I was like, can we keep our clothes on? They said, yes, please do. We're interviewing scientists. We don't want you to do that. No, that conversation never took place. They put as much of it as they can on YouTube, but you can also buy the episodes individually on iTunes or on Amazon. And in each episode, they go to a different part of the world and they ask people, what do you see happening? And then they bring in a scientist and they say, is this legitimately linked to climate change or not? They go to Syria, they come to Texas, they go to Greenland, and they go to the South Pacific. They go all over our world and they put a human face on the things that are happening around the world. Because the reason we care about climate change is not the polar bear. The reason we care about climate change is because our civilization is built on the premise that our climate will be stable. It determines where we grow our food and what type of food we grow. It determines how we design our buildings. It determines how we used to design our buildings in Texas before the invention of air conditioning. But here's the problem. What happens if that climate is no longer stable? We still have our bumps and wiggles. We still have our wet and dry, cold and hot. We still have all our patterns of natural variability, but the long-term average is changing. That's why we care. 2/3 of the world's biggest cities are within a few feet of sea level. Let's make that a meter. Sea level is going to rise at least a meter over this century. If it were 1,000 years ago, what would we do? We'd pick up our tent and we'd move. Big deal, right? You cannot pick up New York City and move it. You cannot pick up the Vancouver airport and move it. We have built ourselves into this problem. We have painted ourselves into the corner. That's why we care about climate change. It's a people issue. And not only that, but when we look to the future, and this is specifically the work I do, when we look to the future, we see that the changes we expect in the future depend on the choices we make today. Are we going to continue to depend on fossil fuels as a primary source of energy, or are we going to be able to transition in a sensible way to alternative sources of energy? The outcome depends critically on the choices we make, not at the end of the century, but now. The way I think of it is as if we're going to a doctor and we're getting kind of a whole body scan. The doctor says, you know, your arteries aren't looking that good right now. I recommend a change in your diet, a change in your exercise and lifestyle, and maybe some medication. And you say, hey, you're in the pain of drug companies. I know what you're all about. Forget it, I'm fine. Fast forward 30 years, you are on the operating table ready to get your chest cracked open for people might have surgery. And you say, whoa, I'm sorry, doc, I believe you. I'll even apologize to you. I will go vegan. I will join an exercise club. I will do whatever it takes. And the doctor's like, that's nice, but it's too late. That's why I do the work I do. I look at what is going to happen to us in 30, 50, 80 years, depending on the choices we make today, because the opportunity is now, not then. And for many of us, this is enough. For many of us, looking at our dwindling water supplies, this is our drought in Texas, looking at the spread of infectious diseases as it gets warmer, looking at the impacts on our food and even eventually our wallets, for many of us, this is enough. Because science tells us that climate change will affect our quality of life, our resources, and even our economy. But it isn't just about science, remember? So now let's go back to the faith part. We've talked all about the science, where does the faith come in? It starts here, I believe. If we look at who has contributed the most to the problem of climate change as a nation, if we look at per capita emissions, we don't look so good, so don't get all smug. We look very bad if you look at per person, so we don't have that many people. If you look at who has contributed to the problem and who is bearing the impacts of the problem, here's where our values come in. If you look at what areas are at risk from being flooded from sea level rise in this century, we will lose half the Everglades and most of the Florida Keys. But in Bangladesh, they will lose the land that houses 18 million people and half their rice growing area. That is what they will lose. And they know it, believe me. When we look at our glaciers melting, we say, oh, well, we won't have Glacier National Park anymore. 1 billion people will not have fresh water anymore because that's where they get it from. This is the glacier that supplies the city of Lima, Peru. 8 million people, 2 inches of rain a year. This water flows through irrigation channels, some of which were built by the Incas. That's how long they've been using this stuff for. The glacier melted so quickly that they had abundant water the last couple of decades, and then just it ran out. It was gone. They had to build a desalination plant, and they were lucky that they could. Many countries are not so lucky. A number of organizations have climate witness programs where they actually find people. They put a face on this and they say, what do you see happening? This man, Augustine in Ghana, says that we have 2 seasons in Ghana. We have the wet season and the dry season. We farm in the wet season. When I was a child in the mid-70s, we got our rainy weather around March like clockwork every year. We could count on it. It always came. But now the goalpost has shifted. And over the past 20 years, it's become increasingly difficult for farmers to predict when the rain comes. It starts late, it's more erratic, we get floods, we get droughts, and then we get little in between. The impact here is that there's not enough water for our animals. The animals travel far, they end up being stolen, often they die. It is my conviction that the explanation to such outcomes are connected to the issue of climate change. And they brought in a scientist and they said, is that true? And the scientist said, yes, we do see that connection. So here's where our faith comes in. It isn't just about us. It isn't just about our comfort. It isn't just about our safety. There's a different reason for caring. And that's because the Christian faith is built on the premise that we are to love and care for others, especially those who do not have the advantages and the resources that we do. That is why our faith is so central to this issue. Because our response is going to be pretty different depending on whether we're looking out for number 1, or if we have our eyes on our brothers and sisters, both here at home as well as on the other side of the world, who are less fortunate than us, who are already hurting, who are already scared, who already don't know what to do and are asking literally, why are our brothers and sisters back over there in the western part of the world, why are they not paying attention to what's going on when we see it every day? There's a big difference between those 2 perspectives. So let's close with this. What do we do about all this? Isn't that tough? It's easy to talk about a problem, but not so easy. It's tough to talk about it. But how do we respond? And especially, how do we respond when, not so much in Canada, but more in the States and some in Canada, you ask people, is there solid evidence that this problem's even real? And white evangelicals, of whom I am one, 2/3 say no, it's not even real. Why do we disagree? It isn't because of our theology. We pretty much all agree that loving your neighbor is important and that God created the earth and gave it to us to be responsible. We pretty much all agree on that. We're also not idiots, I like to think. Now you may say, well, so-and-so is. Well, I'm going to leave that to you. I'm just going to say most of us are not idiots. We are also very compassionate people. We are not saying these things because we are not compassionate, and it's not because the science isn't clear. We nearly all would agree that God's created the earth and that that's good, that we were given the responsibility to care for God's creation. Even if you want to use the word dominion, just think of a king or even a dictator. What is the hallmark of a good ruler? It's caring for what you've been given, not running it into the ground and trashing it. Respecting what God has given us is a sign of our respect for God. And loving others is how we express Christ's love to the world. We would agree on these things. So why on earth are we in the situation we are? I think there's a couple of different reasons. I'm just going to offer a few of them out of many. Many people will say, God wouldn't let this happen. You heard that? Well, I have news for you. Bad things happen all the time. Why do they happen? Many of them happen as a result of choices that we make. We decide to lead a certain lifestyle, and we end up with health outcomes because of that. You know, the operating table, the bypass surgery. that is the consequence of the choice that we made. We have a drink too many, we get behind the wheel of a car, we have an accident. Best case scenario. Worst case scenario, we injure or even potentially kill somebody. Bad things happen to good people because we make choices. And the Bible is very clear that we reap what we sow. That's all climate change is. We made some choices. The choices were great. They brought us tremendous benefits. We wouldn't be here today. I would not be alive today if it wasn't for the Industrial Revolution and the enormous benefits in medicine and technology that it brought us. So the Industrial Revolution was good, but there were some negative consequences we did not know about at that time. And that's what this is. People also say, however, that the solutions challenge not our theology, but our politics. And here is a shocking graph to me, okay? Let me explain what this graph is before I show you. This is showing the issues on which Republicans and Democrats in the states, just to remember, Republicans are conservative, Democrats are liberal. It's very confusing because the colors are switched. It is so confusing. So, they asked Democrats and Republicans, they asked conservatives and liberals, what issues do you most disagree on? Okay, so these are the most polarizing political issues, okay? So if you were thinking of the states, what are the most polarizing political issues that you could think of? You know, probably abortion, gun control, maybe immigration, and obviously the performance of the president, because that is why you are one or the other, right? Okay, so I'll give you a clue. President's number one, so people disagree the most on the president. What is number two? Climate change. Climate change is number two. Number three is gun control. Number four is, do you trust scientists? I mean, can you believe that? And then you have the Arctic and weather right behind that. So 3 out of the top 5 issues that divide conservatives from liberals in the States are related to climate change and science and weather. I never thought I would see the day when climate change was ahead of gun control, abortion, the death penalty, evolution, and genetically modified crops. Yes. Very interesting, isn't it? But here's the thing. Now, this was a study by a colleague of mine called Don Evans, who I'm attempting to educate. People are not aware of the fighting words implied by fundamentalist. I had to tell a few colleagues, please do not call me a fundamentalist, because that means something a little different than what you think. So, but I have not adopted my John education plan before he wrote this paper. So take this with he did not intend any insult by this. He's a very nice man. Compared to people who are not actively religious, people who are actively religious, let's call us Protestants, are less likely to believe the conclusiveness of climate science. But here's the kicker, okay? Why? It's not participation in church, otherwise known as fundamentalist Protestantism. Yeah. It was correlated with age and the political party that you're affiliated with. Why is that? We don't have a pope who gives us pronouncements on these issues. Most of us don't even have the Archbishop of Canterbury, although some people do. We don't have these large hierarchical churches that issue position statements on things. So where do we get our opinions from? We get them from people we trust, people who we believe share most of our other values. And most of those on the internet, social leaders, political leaders, thought leaders, but not leaders in the church. And they may not share our theology and our beliefs. So that, I believe, is why we're in the mess that we are. So, where do we go with this? We have to acknowledge there's some other things going on. In the States, denying the science has become an article of faith. And I'm not joking, I swear it's on the statements of faith of some churches almost. It's certainly on the statement of faith of the Republican Party. And people are afraid. People are very afraid of the solutions because we've been told the solutions involve taxes, tyranny, and the economy versus the environment. Where do you think this picture was taken? I'll give you clues, not states. It wasn't BC either. It was Australia. At the bottom of every strong, negative, angry reaction that we have as humans is fear. We are afraid. We are afraid of the solutions. We are afraid of the change. We are afraid of what it means for us and our comfortable lives. But here's the thing. Our God has not given us a spirit of fear. That fear does not come from God. We have a spirit of power, of love, and of a sound mind. Now that's not a cool, catchy word. But it's amazing to think that God gave us a brain and wants us to use it. To look at facts and information and make responsible decisions that are not made out of fear, but they are made out of love and out of care for other people. We know that everything's permissible, but not everything's beneficial. I once had somebody tell me that every time I got in a car and turned it on, I was sinning. And when he said that, I wanted nothing more than to find a Hummer, get in it, and drive circles around him. Because that is not the way to motivate change. We have to recognize everything's permissible because Christ died for our sins of omission, commission, and every other type you can imagine. But not everything is beneficial. We have been given a mind to make good choices. And that is what this is about. It is not about beating ourselves. It is not about wallowing in guilt. It is not about moaning and repenting and holding services where we wail and weep. It is about saying, let's look at the facts. We didn't know all these facts before, but we know them now, and we can use this information to make good choices that both respect the Creator who has given us this amazing creation and also express God's love to others around us. So bottom line, what does this look like? I think it's important to look forward rather than backwards. To think about things like loving others, loving our neighbor, loving God. To focus on the fact that by doing something about climate change, we're also doing some other crazy things, like we're reducing air pollution at the same time. We're saving ourselves money. If every household in Canada replace just one light bulb, that would be like taking 100,000 cars off the road. Isn't that crazy? With an LED, by the way, I'm a big fan of LEDs. They're really nice. We can invest in our local economy. This is where I live in Texas. Wind turbines are going up everywhere next to rusting oil rigs. I visited a farmer recently who, his neighbor had wind turbines up until the property line, and he didn't have any. So, he was a bit cautious because they knew I was one of those climate scientists. But, I was local, I was from Texas Tech, and we discovered that he knew somebody from church who I knew from our church, and so after about an hour, we kind of made our connections. So after about an hour, I felt comfortable asking him, why is it that you don't have any wind turbines? Is it kind of a choice you made, or an opposition to wind turbines? Is there a reason? He said, yeah, there's a reason. He said, I got on the list after my neighbor. I've been waiting 2 years for those wind turbines. I said, oh, you like them? He's like, like them? Of course I like them. The check arrives in the mail every month. He says, I can farm and ranch under those turbines, no problem. But instead of these dirty oil trucks driving over my land all the time, messing up my fields, these guys control the wind turbines from Florida, and I never see them again. So we're not talking about some tree-hugging Texas farmers here. There are no trees in Texas to hug. We are talking about making economic sense. In Australia, last year actually, wind energy became cheaper than coal and gas. This year in Texas, we broke the record for the most electricity generated from wind. Over a third of our electricity in Texas came from wind. But if you look globally, China is leading the way in wind energy. China is #1 in wind. Canada is, what are we, 1, 2, 3, 4, 5, 6, 7, 8, 9 in wind. And if you look at the solar list, we're not even on the list. Germany's #1, China is #2. So one of the other questions they get all the time is, what about China? Well, I'll tell you what about China. China has a plan to go carbon free. They do. China has a plan to go with wind and solar. Even though in Texas we have enough solar to power the world. And if you're worried about the price, this is the price of solar. When it gets to here, that's where it competes with natural gas. Pretty cool, isn't it? a lot of stuff that we didn't know. So you might say, okay, well, all this sounds good, but what can I do? There is no magic thing we can do. Sorry about that. There's no magic thing. But what I strongly recommend are two things. Three things, actually, as Christians. Number one is measure our carbon footprint. Figure out how much of the stuff we each produce. The EPA has a good calculator that applies to Canada as well as the States, but you can find other ones online. The first step to losing weight is stepping on the scales. The first step to figuring out what we're doing is just measure our carbon. And if the carbon calculator is worth its salt, it will give you a list of like 10, 20, 30 things you can do. Maybe for you, you're totally fine with drying your clothes outside. That's what you do. Replace your light bulbs. Next time you buy a refrigerator, not now, but next time, you look at the rating, the efficiency rating. Maybe somebody else, especially if you're pinching the penny students, you're like, well, I could go meatless. I could just have meat one day a week and then I'd be fine the rest of the time. And that's a big way to reduce our emissions and you save money too. So there's no magic thing to do, but it's important to do something. And as churches, we have a bigger opportunity because we can model this to people. Imagine if we got an energy audit for our church or our college buildings. And we got all these different options of how we're going to reduce our carbon and save money. Show people the light bulbs so that they know where they are and where they can buy them. Show people what we're doing. Print out your energy bills. Be good stewards of the money that people are giving us and help people understand how we can change. But the other thing that I recommend, and one of the reasons why I've joined a board of an organization called Citizens Climate Lobby, which is in Canada, by the way, as well as the States, is because we live in a society where we can't solve the problem by ourselves. Climate change is a tragedy of the commons. In England, each individual farmer put as many animals as they could on the commons, but you put too many animals on and what happens? There's no grassland. What that means is we need bigger scale solutions. And that's why I think it's so important that we have to talk to people, talk to our elected representatives and tell them. And this is actually one of the reasons that my colleague Andrew Weaver, who is the premier climate modeler in Canada, left his job last year and ran for MPP and got in. He's the only Green Party representative in BC. You know that? So you have a climate scientist in your provincial parliament. And he did it because he believed it was so important. My colleague Andrew is not a Christian, but at the same time, he was true to his values. And so I want to close with this. I believe that our faith and our science are completely different, but completely compatible and essential to, first of all, understanding. That's what the science does. Science helps us understand. But second of all, respond to the challenges that we face today. And climate change is rapidly becoming one of the biggest challenges we face. Not because it's something new or different, it is hitting us in the ways we are already vulnerable. Climate change is affecting our health, our infrastructure, our water resources, our natural resources, our economy. That's why we care about it. Not because of the polar bear, not because of our grandchildren, but because of what is happening right now and here to us, as well as our brothers and sisters around the world. So to conclude, I feel like we can all share the goal of building a more secure future for ourselves and for our kids, but not just here at home, around the world as well. Thank you. Okay. Oh, that was good. All right, do you want to take that in there?
No, I'll just stand. Do you want to take a break for 1 minute?
Yeah, I'm good.
Okay. So as we prepare for our question period, and hopefully you've written down some questions and maybe prepared to tweet them, there's overflow, so there's some people watching in another room as well, so they can ask questions. If you're in the other room, your question can be tweeted with the hashtag Hayhoe, TWU. So there's the HAYHOE, TW, with a hashtag in front of that, so we can send your...
If I go here, then they can see me better.
Right. So Katharine talked a lot about science and faith, and Bill Strong graciously allowed me to say a few words about a Canadian organization that Katharine's involved with, and so am I. So in the States, there's the American Scientific Affiliation, and I happen to be the president of the Canadian Scientific and Christian Affiliation, which is a Canadian sister organization with the American Scientific Affiliation. And it just so turns out that we have an opportunity this month. If you're interested in joining that, you can find out information at csca.ca, Canadian Scientific and Christian Affiliation. So csca.ca. If you're interested in joining that, if you join the organization this month, it's free for students, by the way. But anyone who joins, whether they're a free member or not, can get a free copy of this book, Real Scientists, Real Faith. I was looking through this book hoping that Katharine was in here, but she's not yet. Maybe the next edition of the book we'll have Katharine in there as well. So think about that organization if you're interested. Also want to just mention in terms of the Q&A, so whether you agree or disagree with what Katharine has said, feel free to ask your question in a respectful manner. Some of us might have controversial opinions or might think that she raised some controversy things, but just try to remember that you're asking your question shortly and succinctly with respect, and Katharine, I'm sure, will be able to answer your question. And if you want to give a speech, however, then you can invest 10,000 hours, get a PhD, and get invited to give a talk here. So tomorrow also Katharine is speaking at 11 o'clock in chapel, which is held in the Trinity Gymnasium, and her title there is Loving Our Global Neighbor. So around here somewhere, Bill Strong has a microphone, so if you'd like to ask a question, please raise your hand, and I'll direct Bill where to go for the question, and Katharine will answer the question. And we'll be sure to end the question period at 8:30, so you can just do that. So I see a one hand so far. So Myron Penner. I don't know everybody in the audience, but I do know Myron.
Now, can I just ask, can we turn off the slides and then the people will be able to see me better on the screen here? Right now I look like a black silhouette. So can we turn off the slides and turn off the lights?
Sure, I think Bill's going to turn off the lights.
There we go. Okay.
The slides might still be there in the background. So 140 characters or less, your question?
I was going to say thanks for a great talk, but I'm not going to say that now, because it's part of my 140 here. A lot of conservative evangelicals are not trustworthy. They don't think science is trustworthy because for them, they think science endorses evolution. Evolution conflicts with how they understand their Christian faith. So if science isn't trustworthy on that, why should we trust the science when it comes to all these pronouncements of climate change? What do you say to someone like that?
That's a great question. It's one I run into a lot. I think on the issue of climate change, I think it's important to point out that to agree that climate is changing due to human activities, we don't have to agree that the world is any more than 300 years old. And we all agree on that. In fact, if we believe that the Earth is only 6,000 years old, we can't even say there are any natural cycles, because there weren't any big ones over the last 6,000 years. So I think there are many points that we can agree on while still disagreeing on others. So often I run into people like, well, if I'm going to agree with science, I have to agree with everything. We cannot afford to wait to address the issue of climate change until we agree on everything, if that's ever going to happen. We literally have a rapidly closing window of time that we measure in years, not decades, to take action on climate change. And I believe that we can take action even though we may profoundly disagree on the age of the universe, the process of evolution, and even many other scientific issues that we have to move forward that way. So it's kind of like triage, you do what's urgent first, and they take care of the rest.
I have a few questions. One is about your opinion of nuclear energy and its role. One is about the tar sands and how to reach our Prime Minister on that, and the role of this university and the people here, because I think Harper would be more inclined to listen to the Christians than others, than the scientists.
Yeah, I would love to speak with them. My parents go to the Missionary Alliance Church, which is the same denomination as he does. And I think he's one of the people who believe that our Christian faith is really in conflict with this issue. The issue of nuclear power and the tar sands and what to do is difficult because there's always pluses and minuses to almost everything. One of my least favorite things is when you get somebody saying, well, climate change isn't real and we shouldn't do anything about it, and anyways, wind turbines kill birds. And it's like, do you really care about the birds? You don't really care about the birds. Don't get me here. But the point is that there's no perfect solution because wind turbines do kill birds, but on the other hand, climate change could lead to an extinction of 30% of the world's species. So, this versus that. So with nuclear, what I study specifically is I study the impacts of climate change. And nuclear depends on having enough cooling water. So countries that have invested very heavily into nuclear, like France, run into serious problems these days in the summer when they have heat waves and droughts because they don't have enough water to cool the plants. So unless you're putting a nuclear plant, kind of up there in, the Yukon or Nunavut, we are going to run into serious reliability issues with our electricity if we're depending on nuclear because we don't have enough water. You might be able to figure out a way to get it out of the ocean, but even the Great Lakes aren't big enough to give us enough cooling water without significantly altering the ecosystems. So it's a really tricky issue, and it's not just about the nuclear waste issue. And it's a reason why I'm glad that I'm not a policy analyst, and I'm just a climate scientist. So.
And the Prime Minister?
The Prime Minister? What was your question about him?
How do you reach him?
I don't. Yeah. I have a policy of not asking to speak with people because I figure that they won't want to listen to me. But if anybody ever invites me, I'm there. So how do you reach him? I'd say the first way I'd reach him is to pray. Because I feel like that's the only thing we can do with this life.
So I just want to give you a few words about my background, just so you know where I'm coming from. My bachelor's was in science, and my master's recently completed was in philosophy. So I agree with you on science and faith, but on that note, because of my philosophy background, I'm wanting to ask what it means when people ask whether climate change is real. And it's like, especially with the philosophy background I have, it's like maybe it could be the way we're asking the question to people, and the way we're approaching that subject, so that we either make the Christian faith less attractive or more attractive. And especially into apologetics a lot, and so it's that much more important to redefine what it is we're trying to ask. And so what does it really mean when you ask someone that climate change is real? And realism is a huge topic in philosophy and science. So.
That is a great question. And I think you really hit the nail on the head, because these days, when you say is climate change real, you're actually not really asking, is climate change real? You're asking, do you agree to a certain set of political and ideological values that go along with it? And so that is why there's so much emotion attached to it, because people, our identities are built on our ideology, on our faith, on our values. And so you aren't asking, do you think this is real? You're asking, are you a liberal, tree-hugging, godless atheist? Or are you a respectable, conservative Christian? And in Texas, that's what you're asking. And to be totally honest, it really is.
And there's nothing in between.
No, either one or the other. And so that's why I think it's so important to disentangle this issue from our values and from that baggage. I want to be able to just talk about, is climate change real, no matter who we are and what our values are, because that is not incompatible with the reality of this issue or addressing it. So that is a great, great question.
So maybe it's time to rethink how we ask those questions and what it is we want to ask people about climate change.
Or tell people. Yeah. Yes. Yeah, definitely. I agree.
So I have a question that came through Twitter.
Okay.
Presumably from the other room, but maybe from here. Katharine, are you a vegan? Do you support vegans for environmental reasons?
I am not. I live in Texas. One of my best friends there is a biologist who was a committed vegetarian her entire life until she moved to Texas, and then she lost so much weight, her doctor said, you gotta find something to eat. I'm not joking. But we have to recognize that there's many ways in which we are contributing to this problem, and what we eat is a big part of that. But again, I feel like saying, thou shalt, inventing a new set of 10 commandments is not the way to solve the problem. But thoughtfully and carefully considering what we do, some of which are the food choices that we make, as well as other choices, is what we have to start doing. And we have to start asking us, is this the loving thing to do? And I think for each of us, the answer will be different. But for many of us, the answer will be to look at our food choices as well as our lifestyle choices.
I see two questions down here.
Yes, there's really two stories around the climate change debate. One is climate change happening? And the other one is, are the models capturing it correctly? And over the last 12 to 15 years, there's been a growing disconnect between the model predictions and what's actually happening. And even the IPCC is now acknowledging that the models are no longer really predicting what they thought they were predicting, that they're grossly over-predicting the amount of heating that's happening. Okay, so what is your view of this?
Well, that is exactly the field I'm in, and I cannot agree with your second statement. My colleague Jerry Meal just published a study 2 weeks ago that showed that when you look at a large set of climate simulations for the last 15 years, that a good proportion of them show exactly the variability that we've seen, which is the fact that a natural cycle is temporarily driving more heat into the ocean as compared to the atmosphere. That's what's happening right now. So that's why, if you remember that the red and then the black temperature, if you pick a short period of time, you can get temperature going up like this, flat, or even slightly down. But it's a sample size issue. If we picked one person and said, well, smoking obviously doesn't cause cancer because great Aunt Lola smoked 4 packs a day and never got cancer. What's wrong with that statement? Sample size. You have to look at a big enough sample. And so when we do that with climate model simulations, we see simulations that show the patterns of natural variability driving that heat into the ocean at exactly this time. And we also see it coming back out in the next 20 years. So the statement that the IPCC has admitted the models are wrong is a false and fabricated statement.
So over to the left of just sit down with another question, I think.
Can I just say one thing? I won't be long. Ross McKittrick just published a paper for the Fraser Institute where he looked at this, and he shows very clearly that the 97% of the models that over-predicted the air temperature. So maybe if you add in the water temperature, it might be a change, but they were looking at air temperature and over-predicting it over the last 15 years.
I would just comment, first of all, that Ross McKittrick is not a climate scientist. And when I want treatment, I don't go to the chiropractor, I go to the doctor if I have a heart problem. Also, publishing a paper from a fossil fuel funded industry as opposed to a peer-reviewed science journal is a little different. So I'm just, laying that out. All that said, though, these are valid questions. So it's important to recognize that we have answers. We know where the heat is. And burying our head in the sand and pretending like we don't know is not the way to move ahead. We may disagree about the solutions of climate change, and Ross McKittrick and I definitely disagree about the solutions. But that's fair. He's an economist, and there are no perfect economic solutions to this, and it's fair to disagree about that. But it's not fair to pick and choose your data to make it say what you want it to say. That's not the scientific thing to do, and I honestly don't think it's the Christian thing either.
You read the paper?
No, I don't read non-peer-reviewed literature.
So let's go to the next question over to your left.
Okay.
This is maybe our last.
Probably not going to get any applause for bringing this up. It's a bit hard for me to work. But throughout history, throughout cultures, for most of the recorded literary history, all around the world, most of them have been what they call agrarian, agricultural. And in that model, in that way of seeing things, basically the more kids you have, the more prosperous you are. You know, the whole quiverful thing, because they're basically slavery. Now we have billions of people on the earth, and you know, we have a bit more sense of dignity for your average person. Right? They have this role in requirement. So,
Yes.
whereas, can we address climate change? Can we reach sustainability without changing cultural conceptions around birth control and having so darn many children? Can we save the planet without cutting down on the number of children we have?
That is the elephant in the room, isn't it? That's a lot. Here's what I would say. First of all, right now, we have enough resources to support everybody if we didn't use so disproportionately more than everybody else. So the first thing to look for, I think, is being more fair and equitable with our distribution of resources. Because we do have enough right now for everybody, just not at our level of lifestyle. The second thing that I really support is education and empowerment of women, because when women get to choose how many kids they want to have, we see a different picture happening. And especially when children's health is supported. I mean, one of the reasons why people have a ton of kids is because a bunch of them die. And so when we improve global health, we are cutting down on the number of children who are dying. We're cutting down on the number of women who die in childbirth, which I'm sure many of us have had similar experiences, or at least we thought we have. We cut down on issues of poverty and neglect and social injustice, and we love people by doing that, and at the same time we let them make choices that I believe will lead to more stable populations. So rather than imposing draconian measures like China did, I think there's some other things we can be doing first that are win-win-wins in many areas, not just climate change.
Okay, thank you. We'll have to end our question period here. If you want to ask more questions, you could still certainly talk with Katharine, who's willing to stick around up here at the front for a while. But I want to give Katharine a great measure of appreciation for her lecture. So thanks for joining us, and thank you, Katharine, for leading us through some interesting and controversial issues and giving us some good things to think about. So tomorrow morning, chapel, 11 o'clock, loving your global neighbor. And those faculty who are having breakfast, 8 o'clock, that's kind of early, but be here.
I know.